Hello class, today we're going to talk about section 8.5 and 8.6 again, and today we are going to focus on choosing a method to factor quadratic equations. By the end of today's lesson you will be able to determine the best method and factor that quadratic equation. A piece of helpful information here, this chart talks about all of the different techniques that we've used and gives you a hint of when to use them based on the number of terms. The number one thing, if you notice it is in red, to indicate to you, you need to pay attention. The first thing you need to do for any quadratic equation is check to see if you can factor out a GCF. That GCF is going to make it a lot easier for you to solve if you can take that out and help you to avoid simplifying at the end. Next, the difference of squares. That's if you are looking at two terms. If you are looking at three terms, the first thing you're going to want to check is that perfect square trinomial. That was one of those two special cases, and that'll be simpler for you to solve. If it is not a perfect square trinomial, you are either looking at a leading coefficient of 1 or some other number, and that will indicate to you whether you can just factor it into the two parentheses right away or whether you need to use the box. And the last technique is factor by grouping. That's with those four terms. So what I'm going to do here is run through an example of each of these just to give you an idea and help you recall what they look like. One other thing you'll want to note is that some problems will require more than one factor technique, and I will go through an example of that at the very end of this video. So first, looking at factoring out a GCF, we want to start that with all of our problems. We're going to go ahead and say 12a to the fourth minus 16a squared plus 24a. All of those terms can be divided by 4. They also can have an a pulled to the outside. So we are left over with 3a to the third minus 4a plus 6. And then we're going to go ahead and check to make sure it's not a multiple technique. We have an exponent of 3 here. We haven't learned how to factor polynomials with a exponent of 3, so we're going to go ahead and be done. All we used here was the GCF factor method. Next, we've got two terms here. Again, first you want to check for a greatest common factor. 21 and 36 cannot both be divided by the same number, so there's no GCF there. Since it is two terms being subtracted, we're going to go ahead and check for square roots, which we have. Square root of the first term is 11n. The square root of the back term is 6. So that means our two answers are 11n minus 6 and 11n plus 6. And that was using the difference of squares method. So that's with two terms, and both of the terms are perfect squares. When we come to trinomials, one thing you want to check before the GCF is for perfect squares, since perfect square factoring makes it easier. So checking 196 does have a square root, and the square root of that is 14. Square root of x squared is x. And then we go to the back, and we take the square root, which is 2. Checking to see if our middle term works out, we got negative 2 times 14x, which is negative 28x, times 2, which is negative 56x. So that middle term does indeed check out. So our factored form is going to be 14x minus 2 squared, and that is using the perfect square trinomial method. Moving on to another type of trinomial, again, you want to check to start by seeing if they are perfect squares. You can take the square root of x squared, but not 48. Next, you're going to want to take a look and see if there is a GCF. 1, negative 14, and 48 cannot all be divided by the same thing. So since we have a leading coefficient of 1, we're going to go ahead and just look at the factors of the back number. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. We are looking for the pair that can get us to negative 14. That pair is negative 6 and negative 8. So I've got x minus 6 and x minus 8. And that's using the x squared plus bx plus c, factor technique. Again, we're looking at a trinomial, checking to see if we can take square roots first. 5 cannot be square rooted, so it's not a perfect square trinomial. Checking for a GCF, 5, -6, and -8 cannot all be divided by the same thing. So this is going to go ahead and indicate to us that we need to use that box method because I have a leading coefficient of 5. So we got 5 times 8, which gives us 40. So our pairs are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. We're looking for the pair that can get us to -6. That's going to be 4 and -10. So drawing in that box, first term goes in the top left, and back term goes in the bottom right. Filling in either order, I've got 4x and I've got -10x. 4x and 5x squared have an x in common. X times 5x gives me 5x squared. X times 4 gives me 4x. 5 times -2 is -10x, and 4 times -2 checks out to -8. So our final answer here is 5x plus 4 and x minus 2. And that was using the ax squared plus bx plus c factor technique. So with this next one, again, we want to check to see if we can take out a GCF. 8, -56, -7, and 49 cannot all be divided by the same thing. So we're going to go ahead and split it into the two groups for factor by grouping. So we're going to take out an 8y squared from the first two terms, and we're going to end up with 8 divided by 8 gives me 1, and then 1y left over. -56 divided by 8 gives me a -7. Looking over here, I want to make sure that that y turns out to be positive in the parentheses, so I'm going to take out a -7, giving me the y left over. 49 divided by a -7 gives me a -7. So my two pairs of parentheses match. So I've got y minus 7, and my second factor is 8y squared minus 7. Since we have two terms being subtracted, we want to go back and double check for a difference of squares. We can't take the square root of y, so that's not a difference of squares. And we can't take the square root of 8y squared, so that is also not a difference of squares. So this is our final answer, and we used factor by grouping. So this last example is one that is going to cover use of multiple factoring techniques. So again, the first thing we always want to check for is there a GCF? Looking at 4x to the fourth, 16x cubed, minus 9x squared, and minus 36x. All of those have an x in common, so I'm going to go ahead and factor out an x, which leaves me with 4x to the third plus 16x squared minus 9x minus 36. Now, since we have four terms, we're going to go ahead and factor by grouping. So I'm going to split that into the two pieces. We still have that x on the outside, and then from the first two terms, I can pull out 4x squared, and when I do that, left over I have x plus 4. Looking at the next two, I can pull a negative out of both of them, and I can pull a 9 out of both of them. So taking out -9, I'm left with x plus 4. So then we have our x out front still, our matching piece of x plus 4, and our other pair of parentheses of 4x squared minus 9. Since we have a difference here, I want to check for difference of squares. I can take the square root of 4x to the second, which is 2x, and I can take the square root of 9, which is 3. So that means that last piece is a difference of squares that I have to break down. So I've got x, which came out from my GCF, x plus 4, which came from the factoring of grouping, and then I'm going to break down that second piece into 2x minus 3, and 2x plus 3. Again, I do have a subtraction, so I want to check for difference of squares. 2x cannot have a square root, so our final answer in the factored form is x and then x plus 4, and then 2x minus 3, and then 2x plus 3. So we used 3 different techniques. First we took out the GCF, then we factored by grouping, then we used difference of squares. If you have questions about any of these techniques or how to use them, please let me know when you get to class.